Derivatives of trigonometric function. In getting the derivative of trigonometric function, there are formulas we need to memorize to answer the function in getting their derivatives. For example, y equals to tangent of x cubed minus 5. We will get the derivative of tangent, and that would be secant square u derivative of u with respect to x. The value of u is x cubed minus 5. And the derivative of x cubed minus 5 is 3x. By using the formula of derivative of tangent, we have y prime equals secant square u times the derivative of u with respect to x. We will gonna put the value of the equation. So y prime equal to secant squared of x cubed minus 5 times 3x. And then simplify. So the final answer is y prime 3x secant squared of x cubed minus 5. And this is the final answer. So for example, in the rule of logarithm of x, we have f of x equals to logarithm of 5x x base to 3. So to get its logarithm, we have f prime of x equals the derivative of logarithm of 5x base 3, and value of u is 5x, and the derivative of 5x is 5. So based on the formula, f prime of x is equals 1 over 5x ln 3 times the derivative of u, which is 5. So the derivative of function, but then so in derivative of natural logarithmic, we have f of x equals ln times cosine 8x. So f prime of x equal to the derivative of ln cosine 8x. So f prime of x equals to derivative of ln of cosine 8x, where in u is cosine 8x and du is negative 8 sin 8x. Derivative of exponential function. We have two derivative rules for the two special exponential functions. First is the derivative of e to the u. In finding the derivatives of e to the u, the rule is e to the u times du dx. And second is derivative of a to the u, where a is any constant and the derivative is a to the u ln a times du dx. For example, in e to the u, we have y equals 5 times e raised to 5x cubed plus 7x. Make sure that the constants stay outside of the function and focus our attention to e raised to the 5x cubed plus 7x. And use the derivative rule in finding its derivative. So we're going to use 5 on our last step so we can concentrate on simplifying the derivative of e to the u. So using the formula of e to the u, we will copy e to the u or the original function and multiply it with the derivative of our exponent, which is 5x cubed plus 7x, and the derivative of this function is simply 10x squared plus 7. And this particular derivative function can be simplified by multiplying 5 to 10x squared plus 7. So, the distributive property will be applied for these two factors. Be used. There's no exponent in the parentheses right here. So, this is the final answer. In second, for AU times ln A times du dx. Using the constant rule, find the derivative of 8 raised to e 3x. So we have two exponential rules in the problem. One is for the constant rule and one is for the e to the u rule. First is find the derivative of the constant, which is a to the u, which is 8 raised to e 3x times ln A, and A is 8 times the derivative of the e raised to the 3x. And the derivative of e raised to 3x is simply e to the 3x times derivative of 3x. So now we have 8 raised to the e 3x times ln of 8 times 3. So now we have 8 raised to the e 3x times ln A, 8 times 3 e raised to the 3x. And this is the final answer. Local minimum and local maximum. So, find the interval where the function is increasing or decreasing, and if local maximum or minimum exists in this particular function. So the function we will use is f of x equal to x squared minus 2x minus 3. Now pretend that we didn't know the phase of the graph because it is basic graph to illustrate. So how we'll get the behavior of the graph in calculus? So step 1, finding the critical number. F of x equal to 0. So the function of f of x equal to x squared minus 2x minus 3. The first derivative number is f of x equal to 2x minus 2 to find f prime of x equal to 0. Just set your derivative of 0 to find x. So x is equal to 1. So this is the critical number that we will use to get the behavior of function. Whether it is decreasing and the second decreasing. And then step 2, then construct a sign chart. So x equal to 1, so on the left side are numbers less than 1, on the right side are number greater than 1. So let's try the number less than 1. So the equation is f prime of x equal to 2x minus 2. Let's try negative 2. And then prove that the first derivative value, so the first derivative is negative. And then the right side, let's try 2. So after this, the f prime of x is positive, so the function is increasing. Therefore, f of x is increasing on 1, infinite, and decreasing on negative infinite, 1, and local minimum exists at x equal to 1.